Welcome back, Calculus. Our objective today is going to be to find derivatives of inverse functions. I have the checklist on the screen. You know what to do from here. So let's first review what is an inverse function. Let's first kind of review the algebra of that. Like what inverse, do you remember? So in an inverse function, you invert or you switch your x and y. So if I gave you f of x equals x squared, where x is greater than or equal to 0, and asked you to find the inverse of that, we would, again, switch our x's and y's and then solve for y. So I'm going to force a pause on your screen. Go ahead and copy the equation I have, and then we will do the algebra together. All right, so if you remember, oftentimes we say the first step is to rename f of x as y. So I'm going to have y equals x squared, where x's are greater than or equal to 0. This is your standard quadratic function, right? So your parabola. Notice I'm just taking the right branch of that parabola. Okay, so now we're going to switch x's and y's. So I'm going to have x equals y squared, and now this will be for y is greater than or equal to 0. And then we're going to solve for y. And so to get rid of the square on both sides, I need to square root. But remember, when you introduce a square root to an equation, you need a what? You need a plus or minus. And this is why we needed to restrict our domain in our original. Because if I don't, now I don't have a function, right? Plus or minus, I have two outputs, a plus and a minus, for all inputs other than 0. So which branch do we want? Well, we want the positive branch because we want y's to be positive. So in this case, I'm going to take the positive square root of x, and I'm going to go ahead and call it f inverse of x. And that would be my final answer in like an Algebra 2 or a pre-calc class, okay? Now, the idea here, the importance of inverses is that they undo each other, right? You can tell I started with x squared, I ended with the square root of x. So when I compose the two, when I take f of f inverse of x, I'm going to come back to my original input, which is x. So please write that in your notes, and then let's take a look at the calculus of this. All right, I'm going to force a pause on your screen. Can you please copy f of x and f inverse of x in your notes, and then leave some space for their derivatives? And then go ahead and make two tables, x, y, and slope for the two functions, and we're going to go 1, 2, 3 in the first column. All right, we are back. So let's talk about this first table. I'm looking at f of x is x squared. So what would f prime be? F prime would be 2x, and again I'm taking just the positive branch so that my inverse function is indeed a function, okay? All right, now let's go ahead and fill in the table. When x is 1, if I plug 1 in here, I'm going to get 1 squared, which is 1, and then the slope dy dx, if I plug that into 2x, I get 2, right? And then for x is 2, when I plug 2 into the original, 2 squared is 4, and then plugging 2 into f prime, 2 times 2 is also 4, okay? F of 3 is going to be 9, f prime of 3 is going to be 6, okay? All right, so now let's see how that's related to the inverse function. So I have f inverse of x is the square root of x, like we found kind of in our warm-up there. If I want to find the derivative, any special rules, anything you need to rewrite? Yeah, we need to rewrite this as x to the 1/2, correct? All right, so then let's take the derivative from there. So that's going to be 1/2 x to the negative 1/2. And let's go ahead and rewrite that just to make our table easier. I'm going to have 1/2 still, my coefficient, and then the negative on the x is going to bring the x into the denominator. The power of 1/2 is going to square root the x, okay? All right, so now let's fill in based on kind of what we know here. So let's come back to our first table. If I had the point, let's just do in general, if I have the point AB on one function, I would have the point BA on the inverse, right? X's and Y's are going to switch. So I can come to my first table and switch X's and Y's. Now in my first row, if I switch 1 and 1, I still get 1, right? So now I'm going to take the X value here and plug it into my derivative function that we got here. So I'd have 1 over 2 square roots of 1, which is just going to be 1 over 2. Okay, all right, coming to the corresponding row here, my new coordinate instead of 2, 4 is going to be what? I'm going to have 4, comma 2, okay? And we can test that if we come back to my inverse function. The square root of 4 is indeed 2, right? Okay, so now if I plug 4 in here, I get 1 over 2 times the square root of 4, right? Well, the square root of 4 is 2, and 2 times 2 is 4. We've seen a pattern. Okay, let's come back here. I'm going to switch my x's and y's. So instead of 3 comma 9, I have 9 comma 3. Now f inverse prime, again plugging back in here, is going to be 1 over 2 times the square root of 9. Square root of 9 is 3, and 2 times 3 is 6. Okay, so from Algebra 2 and Pre-Calc, we already knew, let's see, these columns, right? We knew how to go from here to here, switch your x's and y's. The new part is your slopes, your derivatives. And what is the correlation there? They're reciprocals, right? Not negative reciprocals, just good old reciprocals. And why is that? Well, over here, you had dy dx, right? But now we're flipping x and y's, we're switching them. So now I'm going to have essentially what was dx dy, okay? All right, so here, let's write this sentence together, please. If f and g are inverse functions, and b comma a is on the graph of f, then we know, again, from Algebra 2 and from Pre-Calc, that what is on the graph of g? A comma b, right? Good deal. Now we also know that g prime of a is going to be 1 over the reciprocal of what we got for f, right? But just be careful because we also switched a and b, so this will be f prime of b, right? So let's check g prime of 9. Will you write that, please? All right, so I would have, according to this formula, 1 over f prime, but now I have to figure out, okay, which one went with 9, right? So when 9 was an x value on g, my inverse function, it was a y value on my original, so the corresponding x value on f was 3. So I have 1 over f prime of 3 coming to my bottom row here. That was 6, and that is indeed what we got there. So let's try the proof together. It's very straightforward. If f and g are inverses, then we know they undo each other, right? So when I compose, I get back to x. That's how inverses are defined. So now let me take the derivative of both sides. Any special rule-outs on the left side? Yeah, I need chain rule, right? So take the derivative of the outer, hold the inner, times the derivative of the inner. Now what I do to one side of the equation, I need to do to the other. So the derivative of the right-hand side is 1. Yeah, and I'm almost there. I'm trying to get g prime of x by itself. So I'm going to divide both sides by this piece. So that leaves me with 1 over, there's my reciprocal, right, f prime of g of x, and that is indeed what we were trying to find, right? Because I need to figure out, okay, what is y for this x value, and then evaluate the original derivative there and flip it. Okay, so I'm going to force pause on your screen. Go ahead and copy what I have. This is the strategy, and really I want you to write, this as well as the 2 tables. Okay, so I'm going to force pause on your screen, copy my 2 tables. Okay, so this is our strategy. We're going to do exactly what we did with that first problem where we had x squared and square root of x. I'm not going to go through all that algebra, right? If I don't need to find what the actual inverse is, if I'm just looking for the derivative at one point, let's just quickly find them using how we know functions and their inverses behave, okay? So what you're going to do is you're going to fill in what you know, and you're going to make 2 tables, one for the original, one for the inverse. I've called them f and g here, respectively. Know that they will not always use those letters, okay? They may use f and f inverse. They may use g and h. Just know that your letters will not always be f and g. Also know that you will be given extraneous information on these a lot. So you're going to fill in your table and you're not going to use all that information, which is okay. Just take the time to make your table, okay? So here's what I mean. If you have that, you have a point like a, b on the original function, and you know that the derivative is c, then you're going to come over here in your inverse function and go, okay, I'm going to flip, I'm going to flip my x and y, right? I'm going to change them, reverse them, and then I'm going to flip my inverse. All right, I'm going to force a pause on your screen. Go ahead and copy what I have. We are back. So I can tell that this is an inverse question, right? So I'm going to start by making two tables. Go ahead and do that with me. So my first table is going to go x, f of x, f prime of x. My second table is going to deal with the inverse, which, what did they call the inverse in this case? F inverse, right? So I'll have x, f inverse, and f inverse prime of x. Okay? All right, so now let's come and fill this in with what we have. So we have that f of 2 is 3. So in my original function, I have the point 2, comma 3. And then when x is 2, again on the original, the derivative is 5. So 5 goes here. All right, now we're going to come and fill this table. I'm going to invert. I'm going to switch my x and my y, right? So now instead of the 0.23, I have the 0.32. And then I'm going to, in that same row, right, I'm just going to flip and take the reciprocal. Okay, so now we look, what were we asked? We were asked to find the derivative of the inverse at 3. Well, that is 1/5. And all you need to do is box or highlight the correct answer from your second table in your assignment work, okay? All right, I'm going to force a pause on your screen. I'd like for you to write what I have, then I'd also like for you to try to make your own two tables this time. Then hit continue when you're ready to see the tables. All right, so here are our tables. And what were we looking for? G prime of 3. So I'm going to come and box my answer of 1/2. It is really easy, especially when you have an assignment of only these, to be like, oh, I don't need to do this part. I can skip this. And I get it. But when these come in just like 1 out of 45 multiple choice questions, the writers are really good at kind of putting sneaky numbers in there. And so if you try to kind of jump the gun on these, you'll often fall for those pitfalls that the writers are trying to get you to fall for. So take your time with these, make the tables, and you will do great on them. Force a pause on your screen. Go ahead and copy what I have, and we'll try this one together. All right, so again, I can tell, don't get freaked out by the trig, I can tell that this is an inverse problem because they're asking me for the inverse derivative, right? So right away, okay, I'm going to go ahead and make a table with what do I know, okay? So x, f of x, f prime of x. What's going in the other table? X, f inverse of x, f inverse prime, right? Okay, so what did they give us? Well, they gave us this 1 point, right? They told us that at pi over 4, f of x is 1, okay? So that means if I want to come over here, I can switch x and y, right? I know that I would have the 0.1 comma pi over 4 on the inverse. So now I can tell what's left. Well, I need to figure out what f prime is at pi over 4. Okay, well, let's go ahead and do that. So f prime of x is what? Secant squared of x. So now I need to find f prime of pi over 4. So that's going to be secant of pi over 4. I'm going to go ahead and rewrite that power. Secant of pi over 4 squared. Okay? All right, so yeah, your favorite unit circle, right? So secant is the reciprocal of what? Reciprocal of cosine. So I'm going to find cosine of pi over 4, which is root 2 over 2, and then flip it. So that would be 2 over root 2. That would be secant. Now I still need to square that. So squaring that gives me 4 over 2, which is 2, right? So 2 comes here. So my final answer is 1/2. And just be sure you go and box that for me, please. So I know you don't need to rewrite it all in one statement or anything, just box your answer. All right, I'm going to force a pause on your screen. Can you please copy the table that I have? Okay, we are back. So we want to find g prime of 2. Now, how do I know that I'm looking at an inverse question? Because of that statement right there, okay? That's the mathematical way of saying that f and g are inverses. And this is really common on multiple choice, that you see something like this, where they actually just give you the table for f. It's also really common that they use kind of sneaky numbers to get you to look at the wrong row, which if you just go ahead and take the time to make your second table, you're not going to have that problem, okay? So I'm going to force a pause on your screen. Can you make the second table for me? And then click continue when you're ready to see the second table. All right, so I've got my second table made here for the inverse function, and I want to find g prime of 2, so I'm going to my table for g. When x is 2, the derivative is 1/3, and that's what I want you to box. Again, what they're going to try to get you to do on the AP exam is come look at this row, right? Which this row and this row had no bearing on my answer. So again, they'll give you this extraneous information. Again, if you take that time to make your second table, which is what I'm going to look for on all your homework, I want to see the tables, then you should do really, really well. All right, I will see you all next time.